organic chemistry revision. Okay, the part we did today is really challenging, but I want you guys to understand this part very nicely. Today we did ring activity, ring deactivity, ortho, meta, para, directivity. This part is really complicated. Once you understand, once you have the memory, it is there, then you feel really comfortable. Let's say this is your room that you are talking about. Your room belongs to you, so you are the controller. Whoever secondly comes has to behave accordingly because you are the one who is making rules. Same way, whatever the very first group joining to the benzene ring decides the activity of the second group. Anyway, benzene's characteristic reaction type is electrophilic substitution. Even the second group coming is an electrophile. So the second reaction, the second substitution is again electrophilic substitution. So that electrophiles are coming. If the first group wants to get the electrophile easily, the second electrophile. So that first group is activating the benzene ring. Because electrophiles are attracting towards electrons, if the first group, that is your room, let's say your friend is coming to your room, you welcome very easily, very nicely. So the second electrophile comes speedier, faster. So the reaction rate is increasing. Let's say somebody coming to your room that you don't like, let's say you're like the distant in-law, somebody like that, then you don't like that they are coming to your room. So you are discouraging. How would you discourage? You decrease the electron density of the benzene ring. So the second electrophile feels less electron density, so it's discouraging to come and join. So timidly, slowly, it's coming and joining. So first part is which you are controlling. You are controlling the speed of the second electrophile. And then again, let's say whatever the way they came in, then you make your own rules how they gonna behave in your room. You ask them to keep here and there stuff. You ask them to do whatever the way you want. Then the second rule is the position or the orientation of the second electrophile. So that two different ways are there to control the second electrophile. By the first electrophile, those two are rate of the substitution of the second electrophile and the orientation of position that the second electrophile is going to attach. Rate and position. Alright. So if you are providing electrons to the benzene ring, so you are activating the benzene ring, so the second electrophile gets very easily and rapidly. So those are called ring activators. Ring activators are the one which are pushing electrons into the benzene ring. And then the second part is ring deactivators. Ring deactivators are grabbing electrons away from the benzene ring, so it's discouraging for the second electrophile. So that we have two different versions, ring activators and ring deactivators. What are those two? Ring activators and ring deactivators. What do they do? See, ring activators. Ring activators, they provide their electron density towards benzene ring through inductive effect. And ring deactivators, they drag electrons away from the benzene ring. So it's discouraging for the joining. So ring activators increase electrophilic substitution of the second electrophile. Ring deactivators decrease electrophilic substitution of the second electrophile. We can divide ring activators and ring deactivators into three categories: strong, mild, weak. You guys have to memorize the note, and this part I have given through the note. And then the second thingy is, then we did couple of questions to understand these reaction rates. Then we are moving to the position. Position is actually very important for conversions. Understanding the position, conversions become really easy. But the very first couple of conversions you would feel really challenging to understand the position. Who's dictating, who's controlling is difficult. Alright, so there are three different positions. Number 1 is U because you have the priority, the one which is already fixed. So that other 2 places are identical second places, that is the meta or the position here and here. And then the 2 of these 3 positions here and here, those are called meta. And then the 4th position, one single position, that is a para. So you divide depending on the position they attach, or the para directivity and meta directivity depending on how they are increasing or decreasing the electron density of these positions. So that directivity again going through 2 directions, or the para and meta, all ring activators and aryl halides are orthopara directors. Strong, mild ring deactivators are meta directors. And then we did couple of these questions. Those are the part that you would feel really uncomfortable. I would just say only this one again. Alright, that they want to convert benzene into this compound. Benzene into this compound. See, then already CH3 group join, NO2 join. But the problem is who's joining first. Whether it's CH3, then Friedel-Crafts alkylation, CH3Cl anhydrous aluminum chloride, or whether it's NO2, then conc nitric, conc sulfuric 50 degrees Celsius. How would you decide that? To decide that, you have to determine, go through the table and check. CH3 is just an R group. This is an R group. So that this is O the para director. And then NO2 group is a meta director. But still, the connection between these two, if you count 1, 2 and 2. 2 is the ortho position, or here let's say the position for NO2 is 1, again 2 and 2. 2 is again ortho position. So with respect to each other, these two are ortho, and I have given the para position here as well, ortho and para. With respect to each other, NO2 and CH3 are ortho para. If it is ortho para, who is the controller? The first person is the orthopara director. That's why the second electrophile is going to the orthopara position. So the first one is supposed to be you, your room, your benzene. You are the first one. You are the number 1. You decide who the positions of the other electrophile. So the other positions are orthopara mean you are the orthopara director. So you decide which the second group is attaching. So that here the orthopara director is CH3. So that you are joining CH3 first. First you are joining CH3. See, then it's very easy. After understanding that, very easy. So CH3Cl anhydrous aluminum chloride, then benzene joins with CH3, and then when you add the nitration mixture, since this is orthopara, to ortho position and to para position. Ortho position NO2, and then the para position NO2 here. Whatever you are adding, even it's not nitration, let's say you are adding FeCl3Cl2, then chlorine is going to here and also here. Because CH3 already joined is controlling and directing other groups are going to ortho and para positions. I know this part is really challenging. Because when you guys are doing question, you would understand writing answers are really challenging because you have to focus really well. How much more time you have for the exam? Remember always that you have one single year for your exam, and during that year you have to cover organic chemistry, and then equilibrium, the biggest note, and then the small notes, chemical kinetics, electrochemistry, and you need 14 industrial. You need timing to do questions, and then least you have to do 15 final this exact exam questions, past papers, not model papers. Don't go too much with model papers. I don't believe that model papers improve you guys well. It's always past papers which make you guys go through this marking scheme and memorize marking scheme and understand the style of the marking scheme. Stick to the plan. Trust yourself that you guys can do this. You seriously guys can do this one because 2026 are already showing these big results, already showing, and very promising results are there. So stick to the plan that you guys can do this. Okay, this is the Grand Advanced Level Chemistry. I'm Dr. Asha Mathotaarachchi.